Very brief here. All right, be very brief. 2 or 3 words is all you need.
Yields H plus ions.
Exactly. Yields H plus ions. Also, guys, another term you could see, though, is not just H plus, but what else? H3O plus, which is called what? A hydronium ion. Okay? So both of those are considered really to be the same thing. An Arrhenius base. 3 words. Yeah, exactly. Same thing. Release or yields hydroxide ions. Okay? Hydroxide ions. Now, Bronson-Lowry definition is a little bit different, but somewhat similar. All right, Joe? Yeah, this is a donor, or a, I'm just going to write it differently. It's an H plus donor. And then a Bronson-Lowry base is what? It's the acceptor, right? It's that H plus acceptor. So those are the 2 we've covered in detail. All right. And we've done a lot of practice with identifying those. Conjugate pairs. Which one of those 2 deals with conjugate pairs? Bronson-Lowry, okay? So you want to jot that down as well on your sheet. This is the only one that deals with conjugate pairs. Okay, conjugate pairs. Lewis. This is the one that's different. You only need to know this by definition. This one's different. What's a Lewis acid by definition? What's that? Electron. Yeah, it's an electron pair acceptor. And, excuse me, a Lewis base is what? Yeah, that's donating the electron pair. Remember, we're not going to worry too much about it in this class. Really, you don't really see that too much until you get to organic chemistry in college. That's where you would see that. All right, labeling these 3 reactions. Acid base, conjugate acid, and conjugate base. Who can raise their hand and tell me and label number 2? Let's take a stab at it. Josh? Right? Yep. Be a conjugate base. Yep. Absolutely. So, and here's the reason why that is the way it is. 1, folks, you should know by now your strong acids and your strong bases, and even some of the weak acids and bases. Guys, H2SO4 is sulfuric acid. It should be easy to identify, hey, that's going to be my acid. Therefore, 1, that would automatically make NH3 the base. But also, guys, ammonia is a weak base, and we listed that yesterday in our notes. Then pair them up. If it helps you to draw the lines, those 2 formulas are similar. And then these 2 formulas are similar. So then it would have to be the opposites, right? Because remember, conjugate is what's left over after it, donates a proton or accepts a proton. Number 3. Anybody can tell me number 3? Joe.
Acetic acid.
Acetic acid?
Acetic acid.
Which one, though?
HC2.
Yeah. This is my what, then?
Acid.
Acid. Water is going to be the base.
And then hydronium is your conjugate acid.
Yep.
And acetate is your conjugate base.
Absolutely. Same thing, guys. These 2 formulas go together. It's losing a hydrogen. And then H2O and H3O plus go together. And it's gaining the hydrogen. All right? It's gaining a hydrogen. And number 4. This one's a little bit more challenging. Briley, is your hand up? All right, we'll give somebody else a chance there. This one right here, you're saying? You're saying that's the acid?
No, actually.
Okay, so you're saying this one's the base, HCl. What is HCl, guys? Hydrochloric acid. So again, that's one you have to have memorized. You should be able to know that, hey, that's going to be my acid. All right, then the other one automatically, the other reactant has to be the base. Now, this is where it gets a little bit more confusing. What about on the product side? You want to keep going there, Briley? Yep. Close. Is the what, though? Yeah, conjugate acid. Carbonic acid. No hydro. Remember, guys, if you have a ternary compound, meaning more than two elements, not binary, you drop that prefix hydro. If it's just two, like HCl, that's a binary acid, it's hydrochloric acid. But if it's with a polyatomic, it's just carbonic acid. You put the ic at the end of it. All right? Ic versus, or ate versus ite. All right, that's from the video that we saw the other day with naming acids, going back to our naming rules. Any questions on those ones? All right, moving along. All right, then you have in 5 through 8, it says give the conjugate base. So if we're supposed to tell the conjugate base, what does that mean we're starting with? We're starting with an acid. So who can give me the name of number 5? What acid is that? What'd you say, Brent?
Hydroiodic.
Hydroiodic. I don't know if that, did you say iotic or ionic? Hydroiodic acid. All right. What's going to be our conjugate base there? I minus. Excuse me. Number 6. What do we have there? Ammonium. What's going to be our base, our conjugate base? So here's the thing. This is one that's been confusing people all day in all my classes. Folks, remember, an acid is donating a proton. It's losing one H. That's how we got NH3. But when it comes to the charge, you're subtracting 1 from the charge. So if I have a plus 1, minus 1, what's that going to be for my charge? 0, which is why there's no charge up here. So in number 5, what was the charge that I started with? 0. And I subtracted 1, which gives me what? Negative 1. That's how we got that negative 1 charge on the I minus, which formed iodide. All right, does that make a little bit more sense if you're still confused? Just subtract 1 from your charge every time when it's an acid and you're going to the base. Number 7, what's going to be our conjugate base? HCO3 minus. And number 8, NO3 minus. Okay? Now, it says in 9 through 12, give the conjugate acid. So if we're giving a conjugate acid, what are we starting with? Base. All right? So we have cyanide. What's going to be the conjugate acid of cyanide? HCN. Now, here, it's the opposite, right? What's our definition of a base? It's a proton acceptor. All right? The base is a proton acceptor. So instead of subtracting your H's, you're going to add an H to the formula. And then when it comes to the charge, you're adding 1 to that. So plus 1, that's how we get our 0 charge. Question?
It's an N.
Oh my goodness. I just didn't finish it out. You're right. It's an N.
You were just
Can't completely change the substance. Rookie mistake there.
How would you pronounce that?
This is cyanic acid. Because again, this is a polyatomic, guys, CN, so it's a ternary compound, so you drop that hydro and you just change that. If you called it cyanide acid, it'd still be, or if you called it cyanic or something like that, you just put that ic ending at the end of the, what's that? Yeah, cyanide's like rat poison. Yep, it would kill you. All right, here we go, moving on. Number 10. What's going to be our formula for number 10, the conjugate acid? So think about it. Now, I wrote it like that. That is the correct answer. If you had HO minus, I would accept it as well. But recognize, guys, that HO minus is still hydroxide. But here's why. Why is it not H2? Because, guys, how many do we add at a time? 1. So you had no hydrogens there, so you have to have just 1 hydrogen, not 2. And then the charge was a negative 2 plus 1 equals negative 1. Number 11. There's 2 ways you can write this formula. CH4COO is not correct. Why? Because this is a what right here? No, what is that? It's a polyatomic what? It's a polyatomic ion, guys. You can't change the formula of a polyatomic ion. Alright, so therefore that inside, that right there, in those parentheses stays the same. So you cannot make it CH4COO. You either can write it this way. HCH3COO or CH3COOH. One or the other. They are both acceptable. They are both correct. Okay, whichever one you're going to see that both of the times. What is that acid? Acetic acid, all right? Acetic acid. So that is both of those formulas are acceptable for acetic acid. Number 12, NH4 plus, which is what? Ammonium. What is NH3? Ammonia. Questions about this worksheet at all? You need to memorize the strong acids and then the weak acids. Make sure you have those memorized for your test tomorrow. Make sure you are familiar and that you can do this and be able to look at those. Again, it falls on your shoulders to go through and review this over and over and practice this tonight for your test tomorrow. Oxy acid, something we haven't talked about a ton, but guys, they're composed of hydrogen, oxygen, and a third element. So they have to have it in there. So these are going to be ternary acids. If you want to jot that down. Oxy acids are ternary acids. Okay? Some are listed right here. Sulfuric acid is the number one industrial chemical. It is used to make fertilizers, oil refining, wastewater processing. It's also a defective dehydrator and is found in acid rain and automobile batteries. Common uses. Make sure you are familiar with the common uses tomorrow. Phosphoric acid is found in fertilizers and detergents as well, also in foods and pharmaceuticals. Nitric acid is used to make fertilizers and explosives. Hydrochloric is a common lab acid. It's also found in your stomach. Acetic acid we've talked about. Bitter taste, slippery, electrolytes. They change the color of indicators. We've talked about this already. Arrhenius base, looking for that hydroxide ion concentration. Bronson-Lowry base, hydrogen ion or proton acceptor. Lewis base listed right. Strong bases, folks, are any hydroxides with metals in groups 1 and 2. So those are the ones listed there. But if you have a group 1 or 2 element mixed with hydroxide, it's a strong base. Weak ones are going to have transition metals and organic compounds. So if you don't see a group 1 or 2 element with hydroxide, you know it's a weak base. Okay? The reading you're supposed to do from last night, guys, this is back in your unit packet. So, by the way, make sure you staple that reading page to your packet. The entire packet is due tomorrow, so that crossword puzzle, folks, at the end with vocab is due tomorrow as well. I will be checking over that. You also have a problem set due tonight at midnight. It has been up since Friday. So jot it all down. 10 questions. Here we go. Take a look at this pH scale. All right, it goes from 0 to 14. All right, acidic pHs, folks, are less than 7. Basic pHs are greater than 7. We're going to do a whole lot more with this when we get back from break, as far as the math goes. So we'll learn all about the formulas when we get back from break. There was one formula though in your reading. Oh no, it was the reading from last night. We'll get there in a minute. Okay? Folks, that's why this pH scale is set up so that it's red to the left and blue to the right. Now, with the middle, actually, we have universal indicator. If I have time today, I may show you a demo. Otherwise, you'll see it some other time. Okay? Take a look, guys, at what's happening. As the pH scale values go up, what happens to the hydrogen ion concentration? Okay, take a look at these values. 10 to the 0, 10 to the minus 1. Need a brighter color. Red on red? Yeah, okay. Look at these numbers right here, guys. So it's 10 to the minus 1, minus 2, minus 3. What's happening as we go from left to right with the hydrogen ion concentration? It's what? It's decreasing. Okay? But what happens to our pH value as we decrease hydrogen ion concentration? It increases. So the pH value increases. What type of relationship is this? It's an inverse relationship, guys. As pH increases, the concentration of the hydrogen ion does what? It decreases. Okay? That is one thing you should have gotten from your reading yesterday. As the pH scale numbers increase, the hydrogen ion concentration decreases. We will learn as to why that is mathematically when we get back from break. We can see again, folks, this is an inverse relationship. Mathematically speaking, we will come back and talk about why that is after break. All right, so moving along. What's happening here is you've got an acid and a base. So this is a pictorial diagram showing you what's happening. So the acid, right, by definition, is releasing hydrogen ions. It's donating them away. Whether it's Arrhenius is donating, or, Arrhenius is just releasing them and causing more of those ions to form. And we can see that right here in this picture, right? There were no hydrogen ions before. After we react it with water, it becomes an acidic solution. Hydrogen ions are present. Bases produce hydroxide ions, according to the Arrhenius definition. Okay? We also talked, again, going down here, when we talk about pH, a low pH has got a lot of hydrogen ions. That's what makes it acidic, right? Because we know our definition of an acid has a lot of hydrogen ions. A basic solution, all right, over here to the right, lots of OH minus particles, it's got a high pH. So it's kind of this balance that's having this seesaw, sort of. And we'll talk about the math behind it when we get back from break. But you got to understand the concepts right now. Understanding it now is going to make it easier when we come back and do the math after break. All right? So low pH equals we have lots of H plus ions. Lots of hydroxide ions means we have a high pH. Means we have very little hydrogen ions. That's why our concentration, when we look back here at this picture, the hydrogen ion concentration got less as we went from acidic to basic. Questions? All right, let's take a look here at the questions from your reading. Along with neutral, so we talked about neutral, hydrogen ion concentration equals the hydroxide ion concentration. But right here, if the pH is less than 7, folks, which ion do you think is greater? Hydrogen ion is going to be greater. So pH that is less than 7, which is what type of solution? An acid, an acidic solution, the hydrogen ion concentration is going to be greater than the hydroxide, right? And that should make sense because if you have an acid, acids produce H+. So that ion should be more than the base ion, which is hydroxide. If you have a pH of bases is greater than 7, though, what's it going to be? Yeah. OH minus is going to be greater than H+. And like I said, we will go more in depth with this when we get back and do the math from break. So from right now, we're going to just talk about it at a kind of conceptual level. So when you have made it, that's what your scale should look like. Folks, again, Again, guys, we will do more with this when we get back from break and we start doing the math. We will then be able, and you guys will actually go through and, like I said, and investigate some of these compounds in that lab, and you guys will be able to put a numeric value to their pH.